Well, how can we tell if a chemical reaction has occurred? If we could zoom in and look at atoms and molecules, that'd be so awesome, and that would make chemistry so much easier, because we could actually go in and see what's happening, but we can't. So we have to look at other things that happen around chemical reactions. In a chemical reaction, if we were able to look in, we'd see that atoms are combining with other atoms to form compounds. Whatever starting molecules you have present get taken apart and new ones form. The atoms in one molecule are just changing places with atoms in another molecule. No atoms are harmed in a chemical reaction. But we can't do that, so we have to look at other evidences. So some of the common things that will happen are a color change. If you mix some stuff together and the color changes, that's evidence of a chemical reaction. It's not proof. You can have color changes without a chemical reaction, but oftentimes it is a chemical reaction. So I don't know if you've seen these spoons for feeding babies. And one of the dangers when you're feeding a baby, you warm the food up, and if you don't check it carefully, you can burn the baby's mouth putting food in their mouth that's too hot. Nobody wants to do that. So they've made this color-changing plastic that undergoes a chemical reaction when it's exposed to a temperature that's too warm for your baby's mouth. So you stick it in the baby food, and if it changes color, you know you shouldn't put that in your baby's mouth yet. That is a temperature-sensitive chemical. It undergoes a chemical reaction when the temperature gets too high. Another piece of evidence is formation of a solid. So here we have a clear yellow liquid being mixed with a clear colorless liquid, and we have this brown stuff forming. It kind of looks like a cloud or smoke. If we let this sit, we would see that all of these particles settle to the bottom, and we'd have this layer of brown stuff on the bottom. The reason we can't see through this part, it looks cloudy, is because those particles are larger than a molecular size. They're large enough to block light. The molecules in water aren't large enough to block light, and that's why you can see straight through it. So precipitation reaction of solid forms in previously clear solutions. That's evidence that a chemical reaction occurred. This substance was not there before we mixed those two liquids. Another one is formation of a gas. Do they still have that commercial, plop, plop, fizz, fizz? Oh, what a relief it is. It was on all the time when I was watching cartoons after school. You drop an Alka-Seltzer in water. What happens? It fizzes. What are the bubbles? The bubbles are a gas being formed. The substances in the Alka-Seltzer tablet are reacting with water to form a gas, and that's what we see as the bubbles coming up. Formation of a gas is evidence of a chemical reaction. The gas wasn't there before. This is a new substance being formed. Chemical reactions may involve heat, either being absorbed or emitted, or they can involve light. So here's a photograph of a natural gas burner. Now, we use burners to heat things up, right? You want to make spaghetti, you put the pot of water on the stove and you turn the burner on. Because this reaction of natural gas burning, combining with the oxygen and air, releases heat. It also releases light. We can see the flames. So we've got light and heat being released. Chemical cold packs. These are very cool. Pun slightly intended. So you buy one of these and you can keep it in your car or whatever, and then you sprain your ankle when you're hiking. You take this cold pack and you feel around in there, and there's a seal that you have to break. You squish it around, and magically it starts to get cold. It wasn't cold before. How does that happen? Did you ever wonder about that? Is it some magic? It's chemistry. So some of you, well, no, actually, all of you, wait. It's a little confusing with 3 sections, but I'm grading experiment 3, so you've all done experiment 3. Experiment 3 with the styrofoam cups. There was one of those where you put a solid into the water and you stirred it up and the temperature went down, right? because it was absorbing heat from the water. That's the type of chemical reaction that could be used to form a cold pack. When you mix the substances, it sucks energy away from the surroundings. There are also instant hot packs, or like hand warmers, where substances mix and a chemical reaction occurs and heat is given off. There are also things that emit light without heat, such as glow sticks. Kids love these things. So you take the glow stick, and it's just all boring, and you bend it and you break the little glass piece inside and allow those chemicals to combine, and it begins to glow. It's a chemical reaction that gives off light. Now, we can be fooled. You could have some of these different evidences, and it might not be a chemical reaction. When water boils, here's a picture of water boiling on a stove. Bubbles are forming. Does that mean a chemical reaction is happening? Not necessarily. When water boils, actually when any substance boils, what happens is these particles are just changing from a liquid state into a gas state. And these bubbles are water in the gas state. If we were able to look at the molecules, we'd see that the molecules in the liquid state, the molecules in the gas state, are exactly the same molecules. There's been no new substance formed. No original substance has been destroyed. It's not a chemical reaction. It's just a physical change. So we can be fooled. And there are also chemical reactions that occur without anything that we can detect with our senses. You can't feel a temperature change. You can't see a color change or see a precipitate forming or anything like that. But still, it's helpful to know the evidence for a chemical reaction. Okay, so which changes involve a chemical reaction, and explain your answers. The dreaded explain. Okay, butane burning in a butane lighter. You flick your Bic and you get a little flame. Is that a chemical reaction? Yes. How do you know? We've got heat, and why else do you sometimes flick a Bic? For the light, right? Heat and light are given off. So that's what suggests this is a chemical reaction. How about butane evaporating out of a butane lighter? You flick it, but not enough to spark it, and you just hold it open. That's just a state change. The liquid butane in the lighter will evaporate and escape as a gas without any flame, but it's still butane. So that's no. That's a state change. How about wood burning? Yeah, chemical reaction. How can we tell? Again, we've got heat and light. How about dry ice subliming? You get a chunk of dry ice and you set it in a box and you watch it, and it just looks like it's making smoke, and it just slowly disappears. No, that's a state change. There's no new substance being formed. Now, we can write questions like this that would be impossible for beginning chemistry students to get correct, and that's not my intent on a test. What you're looking for in determining whether these are chemical changes or chemical reactions or not, you're looking for those evidences, but then you also have to ask yourself, is this just a state change? Is something melting, boiling, freezing, subliming, something like that?